All right, here's the exercise corresponding to today's lecture. You want to go through this exercise certainly before you start the next project, um, um, because the next project involves a lot of these concepts. So we covered a lot in today's lecture. So the exercise first walks you through creating two tasks. We'll go through that one together, and then it has you actually use semaphores and then actually use a mailbox. I'll post a source code for those um, in today's exercise area on the website. But try not to look at those until you've gone through the exercise yourself. Again, we'll go through the first part together, which is create a two-task project and download the two-task.cpp file from the course website. So let me bring up NetBurner here. Again, the process, file, new project, NetBurner project. We have to give it a name, to task, and it's a NetBurner device. Toolchain is the type we want to use, and the project type is a NetBurner device executable. So again, remember where this directory is, because this is where our application is going to be. So next, the defaults here for release and debug version are okay. Our target platform is the mod 5270 or the 5270B if that's the version of the board you're using. And then we can just leave, at this point, leave this last window in the wizard. Don't check anything here, just click finish. So we've created the task, but we don't have any source code in it. Again, I provided the source code for the first part of this first exercise. So go to the course website, the EE458 link, the lectures, and then you'll see the two-task.cpp. So on my browser, I just right-click and say save the link as. So let me drag this onto here. You have to navigate to that NetBurner directory that you just created. So MB Eclipse for me, me at C users AR63. MB Eclipse is my workspace, two task, and then save it right there. Okay. Now going back to NB Eclipse, it doesn't show up here. I need to refresh this window, Project Explorer, so it finds it. So I can either right click and say refresh, or you can just hit the F5 function key. And so now it's part of the project. I can double click on it to open it. We'll see what the user main does. It actually creates two tasks, initially using the same function for both of them, but they will be two separate tasks. Notice I've created the stack array outside in global space, global memory space. First argument here is 2 because I'm doing two tasks. Again, if you're doing 3 tasks or 4 tasks, you need to change this appropriately, and then just using the user task stack size, recommended stack size. OS task, I first changed the priority of the user main task to main prio from 10, a very high priority, to 50, which is the recommended priority. And then here I start up my task code. The task code is pretty simple. I do pass one argument here just to illustrate that, and then it's just a while loop saying hello from task, and then it's going to be either 1 or 2 because we'll pass either a 1 or 2 in as our argument data here. And then it delays for 2 seconds and repeats. So here I create the first task. I'm passing it the function pointer, passing in an argument of 1, and then passing pointers to the top and bottom of the stack for this particular task. So notice first argument here is 0, and then the top of the stack, and then the bottom of the stack. And then this first task is created with main prio plus 1. Every task, again, has to have a different priority. And then I'm creating the second task. I'm using the same task code, but passing in a different argument. So we'll see task 1 will say hello from task 1. Task 2 will say hello from task 2. So we have 2 tasks that run the same task code, but everything else about them is different. They have different stacks. They will have different registers. They would have different local variables. And then here again, passing a pointer to the top and bottom of the stack. Notice now that the first argument is 1, so this is a different portion of the array. I have to use a different portion of the array for the stack for this task. You know, if you don't do this properly, things are going to be really messed up. And then a different priority here, main prio +2, check for errors. User main displays application started and then just rolls off the end of the function. So that would cause this user main task to actually delete and free up any resources automatically. So I don't actually call OS task delete here at the end, like which was common practice for RTEMs. I just let it roll off the end of the function. Okay, so now in my project menu, I want to build the project. Notice I have build automatically turned off, so I have to build the project. I see it building here. Looks like it built without any errors, so that will create the application file in the release directory that I need to transfer over. So now from the NB Eclipse memory, I can start up MTTY, the terminal transfer program. Mine's NetBurner's connected to COM4, and then I connect to the board. It's automatically running this an older version of the application software. So again, I hit the reset button on the board and pressed Shift A to get the NetBurner prompt from the bootloader and type FLA return or enter. Go up to the transfer menu, send file text, and then again you'll have to browse to NB Eclipse, to task, the release subdirectory, and select the corresponding application code to transfer over. This takes a few seconds to transfer over. And then it should reboot and start automatically. Okay, and you'll see that we've got one task printing hello from task 1, waiting for 2 seconds, and then printing that same message again. The second task is doing exactly the same thing, except printing hello from task 2. So let's see. Let's go back to the exercise here. So there's a step 2, modify this to tasks and create a second task function that is identical to the existing one. It must have a different name. Change the task creation code so that the second task now runs the new code. So this step is pretty easy, but you need to go through this before continuing and creating a new project. So going back to NB Eclipse here, all I need to do is actually copy and paste this function. But now I'm going to call them task code 1 and task code 2. I know it's not very imaginative, but it's quick. And then in the OS task create routines, I have to change the names correspondingly, task code 1 and task code 2. So now this is setting up for the next part of the exercise where the task code is actually different for the 2 tasks. Here I've got 2 separate functions. The task code is actually the same. Of course, it'll be different in memory, unlike it was before. So Control S to save, build the project, bring back up MTTY, reset my board, Shift A, flash, transfer, send the file, Now after this transfers over and starts running, you won't actually see any difference in the output. You know, I've just duplicated the task code. Okay. But so we should see exactly the same behavior here at this point. But this now has set you up for the next part. And I'll go through that procedure again as well, at least the initial setup on that to get the file transferred over, because we want to create a new SimSync project and then copy our task program over from this step. Okay, but so let me go through that. Just close this project. A new project, new NetBurner project. What I say to call it, SimSync. So SimSync for the new name. And finish. Okay. Now again, I want to copy over that routine. What I can do now, instead of downloading it from the website, actually I could use the File Explorer, or I can just use this import function directly from the project menu. I want to import from the file system. Next, so browse to the directory I want to import from, AR63, NB Eclipse, from the to-task. Directory is where I want to import from, and then it has a list of files there in that directory. The only one I want to import is totask.cpp, and then finish, and then now you'll see it's imported this over. I want to change the name, so let me call it simsync.cpp, and then open it up. And then now, again, it should be identical to the last modification we made to the to-task project. But now continue with step 3 here, where task 1 is supposed to release a semaphore and delay for 2 seconds. Task 2 should acquire the semaphore and then display hello from task 2. So there's no calls to a time delay in task 2, only in task 1. Task 2 is actually going to wait for the semaphore to be released. So a fairly simple modification to our totask.cpp, except now we're going to introduce semaphores. Again, work on that. I'll post my solution to that in just a bit, post it up to the website so you can compare. And then for the last part here, create a mailbox sync project that is based on the code from SimSync. So import that over. Use a mailbox for task synchronization, and pass a 32-bit value from task 1 to task 2. Task 1 should increment the value after sending it to task 2. Task 2 should display the value. Again, task 1 is going to have the 2-second delay. Task 2 won't have any delay functions. You know, it's just going to be waiting on the mailbox. So the output now should look like hello from task 1. It will pass this value across, this count value. Task 2 will read that and display the count value, and then go back and wait on the mailbox again. So again, I'll post my solution to that on the course website as well, but try to work through this yourself. Okay, I think I'll end this lecture and make another video that talks about the project.